Hello everyone, welcome back to my channel. Today we are diving into the most misunderstood but honestly one of the most innovative layer 1 blockchain out there, that is a Sui blockchain. No, it is not another chain. It's not a copying Ethereum. It's not a competing with the Solana go fast at all cost approach. Sui built on the fundamentally different execution model with the move objects and parallelism at the core. And totally I walk through that exactly how it's work, the architecture, execution engines, object model, consensus layers, and why it's the able to do the things other chain literally cannot. This video have a part 1 and part 2. So part 2 will cover the developer flow, move programming, real world apps, comparisons and roadmaps and more. So stick around till the end. Sui position itself as a blockchain for the real-time asset-centric application. Things like gaming, real-time financing, social apps, payment, marketplaces, anything that can't afford delays. It was created by the Meston Labs, led by the engineer who originally built the DIEM blockchain and Move language at a Meta. So this is the not a random new team. This is the people who literally designed the Move security principle from the group up. Sui core design goals is a parallel executions, object-based data models, low predictable gas fees, instant finality for the most transactions, built for the real performance, not white paper promise. So why this video I make? I am making this video because Sui is the growing fast, especially gaming, DeFi, and the object-based app. But most explanation out there is shallow. People repeat the buzzword like parallel executions, move, DAG, mempools, but nobody explain how actually works and why it's different. So this video we will go from the fundamentals to the workflow to the architecture, consensus, move and real examples. So the first question is, what is Sui blockchain? Sui is the high performance layer 1 blockchain that designed for the real time asset centric applications where the ownership matters. That is developed by Meston Labs, created by the ex Meta engineers and from the original DM and the Move team. Uses the Move programming language with an object based data model. Parallel execution is the core design of Sui blockchain. Instant finality for the most transactions, low predictable gas fees due to its storage fund model and effective execution. Built for the next gen use cases, gaming, DeFi, payments, social apps, retail apps, and digital assets. It's not trying to copy EVM, it's a building completely different programming and execution model. What are the problem with the traditional blockchain? Let's talk about Sui exist. Traditional blockchains like Ethereum, Bitcoin, Cosmos chains are the sequential machines that everything has fit in the single global ordering pipeline. Even when L2 help with the throughout, execution is still fundamentally sequential. This creates a bottleneck, high fees, global state contentions, poor performance for the real-time apps. Developer constantly fight ordering issues. So it's not ideal for the heavy frequency app, but like a games, social, real-time DeFi. So how the single lane road, like transaction 1 goes to transaction 2, transaction 3 is modifies, must wait and delayed. Like first is doing, then the second is wait, and third is like delayed happen. If the first and second complete, then is going. Global state is like shared resources must be updated sequentially, 1 2 3 like sequence. Create bottlenecks and high complexity if the single lane road is there with the traditional blockchain. So why scaling is hard? Scaling is hard because you have to monolithic execution, global ordering, every transaction complete to the order. Validators keep getting bottlenecked and global state keep getting bigger. State contentions, complex validators bottlenecked like. This is why scaling blockchain isn't as simple as add more nodes. So like how that work? Input traffic like 1 2 3 4 5, that is a validator node that processing bottleneck, one transaction, two transaction, three transaction, and then next block came output, and after the another transaction pick up, and then next block came, like this kind of that work. So what makes Sui different? This is where the SUI flips everything. Instead of the global state machine, SUI models everything as an object. Each object has an owner, an ID, an version, a type, and data. Ownership determines parallelism. If two transactions don't touch the same object, so SUI doesn't parallelize and optimize. It's parallelized because of how its data modeling is designed. So SUI is object-based storage, parallel execution by default, that all our transactions doing like parallel, fast path execution for the single owner transactions, instant finality, sub-seconds like move languages for the safety, and high throughput without complex sharding. So here's the SUI design philosophy is very simple. Asset first, safety first, and performance from the fundamentals. Developer first, UX first, and like asset is the first class citizen in the SUI design. The safety is first, speed for the move resources, UX design first, developer friendly architecture. So it's not like trying to be universal word computer, it's a trying to be the best chain for the application and the end user. So what are the objects in SUI? This is the important slides in this video. So everything is an object. NFTs, coins, games, items, pools, profiles. Each object has an ID, owner, version, type, and data. Like that NFT, if coin, if anything, like any object is there, that all have ID, owner, version, type, data, all the things. They have all the subject, that all are the object, and they have each of that their own ID, version, all the data. So object is the key to parallelism. The type of object, here's the owner and what are the use cases. Owned objects is a single owner, then they use cases of the NFT and games item. If the shared object, then they have a multi-user, so that is going to AMMs, DAOs and vaults. Immutable object means no owner, so that config and metadata. So there are the three kind of object. On objects is owned by the user, can be updated independently. Share object is a share by the multiple users, so require consensus. And the immutable objects can't be changed after creations. So there is on object is a fast path and the share object is a slow path, because they need a consensus, they require the consensus, so that is a slow path, and on object is a fast path. Why object model matters? Object allows SUI to avoid goal state conflicts. Instead of every transaction competing for the global ordering, they compete only when the object is shared. This makes executions like predictable, safe, scalable, perfect for the games and the social apps where the millions of the items can updated in the parallel. So that object is enables the parallel executions, avoid global state conflicts, cleaner and safer programming, predictable executions path, and perfect for the games and social apps. What are the difference between them? Let's look visually. Like sequential blockchain is the everything in the queue, all transaction fight for ordering, like everything in the queue in the one line. There is 1 2 3, then it's one line for the order, execute and finality. And parallel means like a SUI, only the shared conflicting transactions need coordination, like multiple lanes. There is a transaction 1 lane, 2 lane, 3 lane, 4 5 lane, like that way. Only transaction interacting with the same object need ordering. This is why SUI can scale horizontally. It doesn't need a global consensus for the most transactions. How SUI achieves parallelism? Parallelism comes from the ownership. If users game item their own object and someone else their own object, both objects run instantaneously. No consensus, no mempool ordering, no blocks. Like object ownership determines no conflict object, instant processing, no need for full consensus for the own objects. Like owner 1, owned object 1, owner 2, owned object 2. Then instant processing due to ownership based parallelism. They updated for the request their own object, so that immediate update after the owner 1 requested, and here's the owner 2 requested, and that also immediate update. No consensus required for the own object because they have a own object. If they have a shared object, then they have a multiple owner, so they need to be consensus layer. So SUI consensus overview. SUI uses two systems working together. One is the Narwhal, that is a data availability and DAG mempool, and the Bullshark is the consensus ordering for the shared object. In that, Narwhal ensures that the organized in the high throughput directed acrylic graph, and Bullshark run consensus only when needed. So that like Narwhal layer is like that work and Bullshark layer like that. Transaction submission, the mempool management is there, and data availability, and the shared object, because here's the on object, and here's the using a shared object detection. So the consensus protocol is there, and the order finalization and the finalized transaction after that. So they both together run. So what is the Narwhal? Also say like the DAG mempool. Narwhal is not a consensus engine. It organizes transactions, ensure data availability, remove bottleneck from the old school mempools, provide a DAG structure so consensus can fast. And this is like a DAG structure 1 2 and they go. Here's the DAG structures like this kind of that work, and DAG structures for the high throughput and ensures data availability by the all state and no global ordering here. And then is the Bullshark is there. Bullshark is the BFT consensus engine. It's used only when needed a share object. If there is a share object, then the Bullshark is needed. If that is a owned object, then Bullshark is not needed. So the heavy consensus work happens far less often compared to Ethereum and Solana, because in Ethereum and Solana they have to be in the consensus layer all the time, and here the only shared object do this. So uses a DAG from Narwhal, and high performance and low latency means like transactions happen the fast way. So the DAG structure, the DAG collection is there, and the block formation is here, and the block finalization. Then created the block 1, block 2 and block 3 in the Bullshark BFT consensus. And is the Bullshark is calling like a BFT consensus, and the Narwhal is called like the DAG mempool. Then we discuss about the fast path versus slow path. So there is a two path. The fast path is for the owned objects, so no global consensus, instant finality, parallel executions, and the perfect for the games and the social apps. And the second is the slow path, and slow path is for the shared objects. So here's the shared mempools, order books, need consensus, still fast due to Narwhal and the Bullshark. So here's the like user, and here's the own object, and here's work shared object. Own object is a fast path, instant process, no consensus, and all thing needed they are completed. And the Bullshark is with that consensus mechanism. So that is a slow path, consensus required, and order finality. But then also that is work, it's faster than the Ethereum. The next is transaction anatomy. A SUI transactions include the sender, gas, object use, programmable transaction data. It's like capability plus logic. The programmable transactions allow multi-call atomic executions. Here's the single owner transaction workflow is there. How that single owner work. The signer send and sign transaction. In the parallel execution, the transaction process transaction 1, 2, 3, whatever the transaction, that transactions are the parallel processing. All transactions run parallel, and the Narwhal DAG is working, and the submit result. They with that submit the result, and finality achieved in the under 1 second. The finality layer, in finality layer, and that is confirmation goes to the signer. That is a single owner transaction work. And after the shared object transaction workflow is like that is a client is a submit request, and if the return signature, and the submit for the sign. Here's the signer, and that after signer submit the signed transactions, that goes to Narwhal, and the mempool processing is happen, acknowledge receipt is going there, and the forward transaction, if that is confirmed, then this forward transactions going, and the consensus protocol transactions validations happen with the Bullshark. Before that, in this there is no need to be Bullshark, and here we need a Bullshark. So the consensus achieved, and the send final transactions there, execute and verify the transaction by the executor, and execution complete, and the confirm finality is going to the client, and the transaction complete. That is the little bit more workflow, like a transaction workflow is bigger than the On object workflow. On is like is the four only layer is there, and here's the five layer is there, and they goes and come for the confirmation. So in the single owner, there is no consensus, so no waiting. This is the Suis feels instant. And the share object transaction workflow is only used when multiple users need the same object. So why move? Move is literally designed for the prevent asset bugs. It ensures the ownership at the language level. No reentrancy, no accidental copying, no loss of funds because of the wrong types. This is the why Sui uses a move instead of solidity, because like Sui language written in the move. So now we discuss what are the Move core concepts. The Move has a resources, structs, modules, capabilities, and entry functions. Move is a strict by design. You can't mishandle assets. So that is a strict by design. And here's the Move resource safety. So this is the where Move shines. No silent copying, no accidental detections, explicit transfer cementing. Like it prevents from silent copying, double spans, accidental detections, reentrancy, implicit transfer because everything is explicit and typed. That successful resource transfer pass unique ID and the return that ID and error case automatic cleanup. So move resources work like this way. By this diagram, you can understand this. That is the foundations of SUI. You now understand object models, execution model, parallelism, consensus, move basics. Like SUI works with the move, not in solidity. But this is the half story. This is the only half story. In part 2, we explored the developer setup, project structures, programmable transactions, gaming, DeFi, NFT, security, and what are the roadmap of 2025 to 26, and full comparison with this Ethereum, Solana, and Aptos. So part 2, go watch it next. And thank you for watching.